Okay, hello everyone, and today we'll start lecture number 18. It's about the stability in binding, and if you remember in the last class, we basically spoke about the periodic table, right? And we said that the periodic table, which was done initially by Mendeleev, we put all elements together in one table, and if you remember, Mendeleev organized those elements based on three criteria: based on their mass number, based on the physical properties, and on their chemical properties. Then after him, Moseley came up with another idea, which is organizing the periodic table based on the atomic number instead of the mass number. Now, we also learned why the periodic table can be organized in periods and groups. We said that the periods are the rows and the groups are the columns. So we said that the periodic table has 7 periods and 18 groups, and we've mentioned how those groups and periods and why are they organized this way, why elements exist in such and such periods. Okay, now if you remember, we have also learned about something called compounds and something called mixtures, right? And we said that mixtures means like if you have a dish of salad, you mix like tomatoes with cucumber or with lettuce, and so that's called the mixture. There is no chemical interaction between the different parts of the mixture, but in a compound we have chemical bonds and we have specific percentage or specific ratio between the different parts of a compound. Okay, now let's look at this picture, and here you can see the Statue of Liberty, United States. And if you check the color of the Statue of Liberty, you will see it's kind of greenish, grayish color, right? And if I tell you that the Statue of Liberty is covered with copper, and all of us know that copper is a brownish reddish element, right? So if you look here, this is not brownish, this is like greenish. Now why is that? It's because the copper interact with the sulfur in the atmosphere. It makes the copper sulfate. But wait, like if you look at the sulfur, you will notice that the sulfur again is a yellowish, light greenish element. So when these two combine, they give another color, totally different color, right? Which is the copper sulfate. So that confirms what we have learned before, that the compounds are having totally different properties than the elements that make up the compound. So this is very important to learn, that compounds are having totally different properties than the elements that make up the compound. Now we have other example here, which is the reaction between the potassium and the iodine. Now potassium is a metal and iodine is an element that makes sublimation. Now remember this word, sublimation. And sublimation basically means that you go from the solid state directly to the gaseous state without passing through the liquid state. That's what we call the sublimation. So when potassium interacts with the iodine, it makes the potassium iodide, which is a salt. You can see this is a salt, like the table salt that we use at home. And again, it's totally different than the potassium and the iodine, right? It's the potassium iodide and so on, right? So again, we repeat the statement that compounds are having totally different properties than the elements that make up the compound. Okay, and now next thing we talk about here is called the chemical formula. And in the chemical formula means that this is like how we represent the compounds using chemical symbols. For example, I have this sand, which is the silicon dioxide, is SiO2, and the cane sugar is C12H22O11. Now, of course, if I ask you how many carbon atoms are there in the cane sugar, to be 12, how many hydrogen atoms, 22, how many oxygen is 11, Now same thing with the sand or the silicon dioxide. So I have one Si and one O2 and so on, right? So do we need to memorize this table? The answer is no, and also we don't need to memorize even the periodic table, right? We just need to be able to extract how many atoms are there in each one of those compounds listed. Okay, now we go now the next important thing, which is the chemical bonds, which is why certain elements interact with other elements to make compounds. Like for example, why Na interact with Cl, for example, to make the table salt NaCl. Why potassium interacts with the iodine to make the potassium iodide, for example. Why this is happening? Why such element interacts with certain elements in the periodic table. Now, if you remember, we have mentioned before that the periodic table can be split into 18 groups, 1, 2, 3, 4, 5, 6, 7, and up to 18. And we've mentioned that all elements in the group number 1 are having only one electron at their outermost orbit, and electrons at the second group are having 2 electrons at their outermost orbit, and the same thing will happen from 13 to 18. So 13 elements in group number 13 are having 3 electrons at their outermost orbit, 14 are having 4 electrons, 15 are having 5 electrons, and so on, right? So this number of electrons is what we call the valence electrons. If you remember this word, it's called the valence electrons, which is what? Which is the number of electrons at the outermost orbit of those elements, right? Now let's look at the sodium, and we will notice that the sodium is having only 1 electron at its outermost orbit, right? Now, is that stable? The answer is no, it's not stable. Why? Because for this to be stable, it must be 8 electrons, right? Now, let's look at the chlorine. The chlorine belongs to group number 17. It means that it has 7 electrons at its outermost orbit. Now, again, is that stable? The answer is no, it's not stable. And why? Because it has to be 8 to become stable. So you see, so this is the thing. The sodium has an extra electron that it wants to get rid of, and the chlorine needs 1 electron to become stable. That's why they like each other. So the sodium will give the chlorine 1 electron. The sodium will lose 1 electron, and the chlorine will gain 1 electron. Now, when an atom loses 1 electron, it turns into a positive ion, and the other atom gains 1 electron, it becomes a negative ion. And as we know, plus and minus like each other, right? So the sodium plus, chlorine minus, they like each other, so they attract and they become the sodium chloride, which is NaCl, right? Now, what do we call this? We call this gaining and losing. Why? Because the chlorine gains 1 electron and the sodium loses 1 electron. Now, when they do this, there's a bond, and a bond means a force, right? There will be a force between the sodium and the chlorine. Apparently, this force exists because of the pluses and minuses, right? So we call this force, we call it an ionic force or an ionic bond, right? So why I call it an ionic? Because we have one of the elements has a plus sign, the other one has a negative sign, of course, or more. Now, if you guys remember, also in the last class, we have learned about something called the electron dot diagram. And it tells me, and the number of dots tells me how many electrons are there at the outermost orbit. So here for the sodium, I have only 1 dot, and for the chlorine, I have 2, 4, 6, 7 dots. It means that the chlorine has 7 electrons at the outermost orbit. So this sodium will start to lose this 1 electron, and the chlorine gains the 1 electron. The sodium turns into plus, the chlorine turns into minus, and so on. Now, can the same thing happen with the group number 18, which we call the noble gases? And the answer is no. Why? Because they have their outermost orbit completed, and they don't need to gain or lose any electrons. Okay, now let's take another example here, which is the water molecule. Now we know that the water is H2O, so it's made up of one hydrogen, one oxygen and two hydrogen, right? So let's think about it. Now we have the oxygen, and we know that the oxygen belongs to group number 16, so it has 6 electrons at the outermost orbit. Now, is that stable? The answer is no, it's not stable, because it must be 8 to become stable. So the oxygen will go to the hydrogen and say, hello hydrogen, can I get 2 electrons from you? The hydrogen will say, no, sorry, I cannot give you 2 electrons because I have only 1 electron at the outermost, and I even need 1 electron. So look at this. The oxygen needs 2 electrons and the hydrogen needs 1 electron. So that's why the oxygen will make a deal with 2 hydrogens such that it shares 1 electron with each one of the hydrogen. Now remember that there is no gaining or losing here. Nobody will gain, nobody will lose. All what they do is they will share. So the hydrogen will share 1 electron with the oxygen, and the oxygen will share 1 electron with the hydrogen. So now the oxygen will think that, or will feel that it has 8 electrons at the outermost orbit. And the hydrogen also will feel that it has 2 electrons at the outermost orbit, and the same thing with the other hydrogen will feel that it has 2 electrons at the outermost orbit. So if you cannot imagine this, think about me and you are sharing a car. You use the car in the morning, I use the car in the afternoon. So both of us feels happy because both of us feel that we are having a car, or we are using a car, right? So if you ask me, do you have a car? I say yes. And if I ask you, do you have a car? Then you will also say yes. But in reality, the car rotates between me and you all the time. The same thing will happen here when those electrons share the electrons. Now, when that happens, a bond will happen between these 2 atoms, and what do we call this bond? We call this bond the covalent bond, right? So the covalent bond is the bond that happens because of sharing electrons. So remember, I have 2 different kinds of bonds. I have the ionic bond, I have the covalent bond. The ionic bond happens when gaining or losing, and the covalent bond, it happens when sharing the electrons. Now, there's something very important I want you to know. Now, think about, for example, the NaCl. Na is plus, Cl is minus, right? But NaCl, which is a table salt, is neutral. It's not plus or minus. You see the idea? Think about potassium iodine. Potassium is plus, iodine, or potassium iodide, sorry. The potassium is plus, the iodine is minus, but the potassium iodide is 0. Okay, now let me go back a little bit, few slides, because here, when we talked about the iodine, you see, here's we say iodine ends with I-N-E, but here we have to say iodide, I-D-E. So please be careful about this suffix, because if the element is by itself, then I use the I-M-E, but if it goes into a compound, then I must use the IDE suffix. Okay, so please try to be careful about this point. This is so important. Now let's finish this with speaking about the bonds, how we deal with bonds. So a bond means a force, and if you remember from your previous physics and chemistry studies, when you talk about a force means to pull something or to push something, right? So here the kind of bond between the elements that make the it makes the compounds is a kind of force, and we call it a chemical bond. Now the chemical bond happens when atoms gain, lose, or share electrons, right? Gaining, losing, or sharing, and attraction is created between the atoms that pull them together. Okay, so I guess this is all about this lecture 18, and I will see you inshallah in next lecture. Thank you so much for watching our channel. Thank you.